Good day for you. You're welcome to another of our classes. Today we'll be focusing on transforming trigonometric graphs. Our major focus today is on trigonometric graphs, and the focus of our class is the ability to sketch the graphs of the trigonometric graphs, and also you should be able to analyze the graphs and do the transformation of the graphs. Lastly, you should be able to explore the concept of radians and transformation in trigonometric graphs. So this is the major focus for this class today. We are off this, we have done what trigonometry is, so we know our sine and cosine, and tan is what we are focused on. So we are going to look at this, sketching the graph of the following function. A is y equals to sine theta, and B is y equals to cos theta, and C is y equals tan theta. These are the graphs we'll be sketching on your trigonometry. And after sketching, you should be familiar with this pattern of graphs. You should have a full knowledge of how the sine graphs look like, and how the cosine graphs look like, and how the tan graph looks like. So we start with the first question. The first question is y equals sine theta. So I'm going to do y equals sine theta, and we are going to have a view of what our sine graph look like. So for the values of sine, for the values of theta, I'm going to take theta for minus 90, minus 180, minus 270, minus 360, 90, 180, 270, and 360. So this will be the value of my theta, and I will use that to find the value of y. So first of all, I want to make a table on that, where I have theta ranging from minus 360, minus 270, minus 118, minus 19. Then we have 0. We have 19. We have 118. We have 217. And then lastly, we have 316. So I will have my value for y. I will know y is equals to what? Sine theta. So for every value of theta, I substitute the value I have up there. So the first value is sine negative 360. So sine negative 360 gives 0. Next, I have sine negative 270. Sine negative 270 is equals to 1. And sine negative 180 is also 0. And sine negative 90 degrees is negative 1. Then we have sine of 0, which is 0. We have sine 90, which is 1. We have sine 180, which is 0. We have sine 270, which is -1. And we have sine 360, which is also 0. So you just watch out for the peculiarity of this. Sine -360 and sine 360 are both 0. Then sine -270 is the positive, while sine 270 is the negative. Then sine -180 is also 0, and sine 180 is also 0. Then sine 90 is -1, while sine -90 is -1, while sine 90 is a +1. So having gotten those value for y equals sine theta, we can use that value to plot our trigonometric graph. So on that, I have my graph here with my y-axis. Okay, so I have my y-axis and I have the x-axis. So we have our values. 0 is here. We have our 90, 180, 270. I would like to space it a bit. So I have 90. Father, I wait for that. So 90, 180, 270, and 360. Then on this, we have our -90, -180, -270, and -360 degrees. So we've gotten the values for that. So on my y, also, I'll make here this point to be 1, and this point to be -1. So we can plot our sine graph from the points, the values given. So go back to our table of values. We have where sine -360 is 0. So on sine -360, I have my 0 point marked in. Then for sine -270, we have a +1. So this is my +1 on the graph. Then for sine -180, we have 0, which is also 0. Then sine -90, I have -1 here. Then for sine 90, we have, for sine 0, we have 0 at this point. Also for sine 90, I have -1 on this point. On sine 180, we have 0 on this point. For sine 270, we have -1 on this point here. And for sine 360, we have 0. So we've gotten the point of our graph. So what you do next is just to connect the dots together. So in connecting the dots, this is what we are going to have on your graph. So see the way I'm connecting my dots. So this is what our sine graph looks like. So take note of your sine graph using the values from our table of value for when y is equal to sine theta. So you can see the way it's going. Okay? That is our sine graphs. I know those of us that did physics, this reminds us of what? Our transverse waves. So we can proceed to the next question that says y is equals to cos theta. So I have y equals cos theta. We want to get the cosine graph also for same stuff. So y equals to cos theta. What I do, I'll just have to delete this place and make it cos theta. So I have my y equals cos theta. So I'll be finding the cos values of my angles given. So the first one we have there, we have cos negative 360. Gives us 1. Then next we have cos negative 270. It gives 0. We have cos negative 118, which gives negative 1. Then we have cos negative 90, which is 0. We also have cos 0, which gives 1. We have cos 90, which also gives us 0, and same thing with cos negative 90. Then we have cos 118, which gives negative 1 as cos negative 180. Then we have cos 270, which is also 0. And lastly, we have cos 360. So cos 360 is equals to 1. So we've gotten the value for our cosine. Same thing we did for our sine. We are coming to plot for also our cosine graph. So say I have this for my y-axis and same for my x-axis. So since we are using the same values, 0, y, and x. So this is a graph of y sine theta. So I have 90, 118, 270, and 360. Then we have negative 90, negative 118, negative 270, negative 360. So we plot our values. We have here as 1, here as negative 1. So when theta is negative 360, our y is 1 here. When theta is negative 270, we have it as 0. When theta is negative 180, we have it as negative 1. For 90, we have it as 0. Then for 0, we have as 1. Then for 90, we have as 0 here. For 180, I have it as negative 1. For 270, we have it as 0. And lastly, for 360, we have as 1. So if you are confused in the example on how to do this, it's better you use your values for plotting your trigonometry graphs. So this is what our cosine graph looks like. Okay, so take note of your cosine graph. So this is a graph of y equals cos theta. So this is what you just have to connect the dots together to get these curves. So the next graph we'll be plotting for is our graph of y equals tan theta. So we are plotting graph of y equals to tan theta. So I will just replace on my table of value with tan theta. So I have y equals to tan theta. So the first we have there is y is tan negative 360. Which we have 0. And next on that we have tan negative 270. So tan negative 270 is on your calculator, you know that it's a math error. So on that, I'm putting nothing here. Then we have tan negative 118 is also 0. We have tan negative 90, which is also math error. There's no value for that. Then we have tan 0, which is 0. We have tan 90, which is also math error, no value for tan. Then we have tan 118, which is 0. We have tan 270, which is math error. Then we have tan 360, which is 0. So same thing, I'm going to use my table of value to plot for my tan graph. I have this. I have this. Okay. Then we have our y-axis and we have our x-axis for 0. Then we have our 19. We have 118, 270, and we have 316. So for this, we have negative 19, negative 118, negative 270, and negative 360. I have my 1 and negative 1 on this. Okay, so having gotten that, so we can go ahead to plot out the values. So when tan is negative 360, our y is 0. When tan is negative 270, it's a math error. So on that, this is what we do. I just draw a line here because there's no value for that on 270. Then when it is a negative 180, we have our value as 0. When it is negative 90, it's also a math error. There's no value, so I'm going to have this line drawn down here because there's no value for that. So when tan is 0, we have our value as also 0. For 90, we have that as what? Math error. Same thing, I will apply here because there's no value. Then for 180, we have it as what? As 0. Okay. Then for 270, also same thing, math error. So I have my value as this, down. Then for 360, what do we have? We have that as 0. So having gotten this, we are going to plot our tan graph. Our tan graph is a little bit different from our cosine graph and our sine graph. So we are going to have our graph this way. And this is for value of 316. I'm going to have something like this here. Then for 180, I will have a curve going this way and here. Then for 90 degrees is already there. We have 4 when tan is 0. We have our curve. So when tan is 180, I have it. Okay, and when tan is 360, so we have tan as 360 and this. So take a look at this beautiful graph of our tan theta. So this is our tan graph. So we have this graph as y equals tan theta. So this is simply how to draw your trigonometric graphs. So please take note of this. This is our trigonometric graphs where we have for our sine theta, cos theta, and tan theta. So always take note, if you can't have this, you can't memorize this graph, you should be able to plot in the values, then you plot your graph. And you should just take note that your sine graph slopes upwards, like the transverse wave. It's coming this way, this way, this way. So this is our sine graph. Then for our cosine graph, slopes down this way. Okay, and this way, then this way. Then for the tan graph, is a graph like this, is a unique graph with this. Then we have our broken lines, which denotes the ones that don't have any value. Then we have it slanted this way, is our tan graph. So it's a repeated pattern. So we have it this way, we have it this way, we have it this way, then we have it this way. So this is our trigonometric graphs we should be familiar with. So this is the graph we drew up for our sine theta, and this is for our cos theta graph, and this is our tan theta graph. So what I want us to take note of here, we should know that the period, which is the length of the wave, is 360 degrees for sine and cos. So we have the length of our wave here as 360 for sine and cos. Then for our cosine, for our time, the period of our wavelength is what? 180 degrees. So take note of that. Period length of wave for sine is 360. Then for tan, we have it as what? 180 degrees. So take note of that. So we also have graphs for rad. You should have in mind that our rad 180 degrees is equals to what? Pi. So take note of that in mind. 180 degrees will give us pi. So that means if we are talking of 90 degrees, we are doing pi divided by 2. So for 270 degrees, this is the simpler way you can do this. If this is half of this, so I'm doing what? So I have 270 divided by 180 multiplied by 5. So this gives us what? 9 here, we give 3, 2. So for 270, it becomes 3 over 2 pi. Is that okay? Then for 360, same thing, we have 360 divided by 180 multiplied by the pi gives what? 2 pi. So you can do this for any angle of your choice. I would just want us to go for 150. So if I'm doing for 150, that becomes what? 150 divided by what? 180 multiplied by pi. So 3 can go here 5, 3 can go here 6. So for any value of 150, it is 5/6 pi. So this is how to make a graph for your radians. So you can see for negative 360 here is 2 pi. Then we have this as what? Negative 270 gives us negative what? 3 pi over 2. Then we have for our 180, which is what? Negative pi. Then we have for 90, which is what? Negative pi over 2. So and so on. So you can also have the same value. We have the same curve even for our rad. So it's the same thing, it doesn't change. So we just change it to your rad trigonometry graph. So these are the same graphs but with radians. Is that okay? So you should have known that 180 already is our pi, which I've done here. So whatever angle we are giving, converting to pi is easy. Just divide that angle by 180 and multiply by pi. We give you your radians. So we'll move further to transforming our trigonometric graphs. So transformation. This is part 1 of transformation. So for example, I have y equals to 3 sine theta. You are asked to work out the value of y equals to 3 sine theta. So in working y equals to 3 times theta, you have the first value, assuming you are working y equals 3 sine 90 degrees. What will it give us? We have our sine 90 degrees. So we have our sine 90 degrees as 1. So that means we are saying y is 3 multiplied by 1. That means the value of y becomes 3. So what do you observe here? You can see that from 1, when y is sine theta, which is 1 here, it will have your y value will have to move to where? 0.3 of your graph. That means the y value has been transformed by how many? 3. So your y value becomes 3 times bigger than what it is. Is that okay? So that is how to transform your trigonometric graph. So in multiplying this, it is transformed 3 times. If I put 4 here, that means the graph is transformed by what? 4 times bigger. So your y value is affected. So in transforming this graph by 3 sine theta, what do we have here? You can see that the graph has been transformed. Our y-axis has been moved to where? From 1 to 3. So this is the point of transformation. And if you look at 270, which was a negative 1, multiplied by 3 becomes what? A negative 3. So negative 3 is the point of transformation for this. So this is how to transform your sine graph by multiplying. So if you have 4, for example, I have 4 sine theta, that means your graph will be what? Transformed by what? 4 times. And that will affect your y-axis. So 4 times y is moving the graph 4 times upward, or moving it what? 4 times downward. So this is transformation. This is the first part of our transformation. So we move further to halving our trigonometric graphs. For example, I have y is equals to half sine theta. And our angle is 90 degrees. That means we are seeing half of sine what? 90 degrees. And we know sine 90 is 1, so that is half multiplied by what? 1. That gives us what? 0.5. So when your sine graph is half, that means the value of y is also what? Halved. Halving the value means halving the value of y. So instead of multiplying, this guy is going to be half. So let's take a look at what the graph of halving this is looking like. Then also that means for our 270, which is -1, also becomes what? -0.5. So it is also reduced. So that is how to transform your graph with multiplying and halving of the values of theta. So this is a graph of y is equals to what? Half sine theta. So you see that our sine 90 is on what? 0.5. Okay, then our sine 270 is where? Minus 0.5. So when you multiply any value by your theta, that means your y-axis is being affected. So your y-axis is affected directly by multiplying theta with any value. So this is transformation of trigonometric graphs of sine theta by multiplying sine theta with any given value. So it affects our y-axis. We'll go to the second aspect of transformation of graphs. In this aspect, we have been y is equals to sine 2 theta. So if you have your value of theta, that is, we are saying sine 2 multiplied by 90 degrees. So that gives us sine what? 180 degrees. So sine 180 will give us what? 0. So on this y, on 90, we have 0. So when you multiply this, that means you have what? The theta values. So say, and that means on this, your y value still remains the same. Okay, then if you have sine 2 multiplied by 180, so we have sine 2 multiplied by 180. This gives sine 360, which is also what? 0. So you have this point here, we have 0, and we have 0. So, but if you take a look at this, your y values for having the value of theta still remains the same. So nothing affects your y value. Same thing when y equals to sine theta over 3. That means for sine theta over 3, I have sine 270 by 3. So sine 270 by 3 gives us what? Sine 90 degrees, which is equals to what? 1. So you can see your y value remains at what? 1 there. So nothing is going to happen to it. So this is how to transform your graphs by dividing theta by 3. You still have the same values for y, unlike multiplying theta. So we have also for y equals to sine 2 theta, our y value still remains the same. Or when y equals to sine theta divided by 3, our y value remains the same. So take note of this transformation of your trigonometric graphs. Now we'll be looking at adding a value to your value of theta. So we have, for example, here y equals to sine theta plus a. This is our sine graph. So we are adding theta. We are adding 1 to theta in this. So that means if our y is sine 90, we are saying y is sine 90 plus 1. So that means sine 90 is 1 plus 1. So that means the value for our y on sine 90 will move to here 0.2, because 1 plus 1 becomes what? 2. So adding a value to your theta also will affect your y-axis. it will shift your y-axis upward. Okay, so when you decrease the value or you subtract from your theta also, that means your y value will move downward. So adding any value to y equals to sine theta plus a will affect your y positively upwards. Then decreasing the value will also affect it downward. So it will reduce the value of y. So that's what we have here. Y equals to sine theta plus 1. Your y value will increase by what? 1. It moves upward. Then when y is equals to negative 2 plus sine theta, for example, we are saying negative 2 plus sine 90, that's negative 2 plus 1, which will give us what? Negative 1. So on sine 90, your graph comes where? Here. So we have the negative 1 instead of our positive 1. So take note of this part of transformation. We have already established that multiplying any value by your theta will affect your what? Your y-axis. Okay, any value multiplied by your theta affects your y-axis, and any value added to your theta will also increase the y-axis. Then any value subtracted from your sine theta will reduce the value of your y-axis in a negative way. Now we're looking at transforming your sine graphs by adding a value of a to your theta. So here we have sine theta plus 90 degrees. If you have sine theta, which is sine 90, for example, our theta is 90, we are saying sine 90 plus 90. That gives us what? Sine 180. So on sine 180 degrees, so we have y equals to sine 180. So you can see our normal sine graph here where y is sine theta. So on 180 degrees, this is what we have here. That is when you have the value of y equals to sine theta plus 90 degrees. So your y will take what? The same set of values for any value less than 90 degrees. But for values greater than 90 degrees, you will see your sine graph this way, which is against this one, moving this way. So that is when you have value of sine theta plus 90. Then what if you are subtracting sine theta minus any given value? So this why we take the same set of values for values that are what? Theta and are 30 more than before. So you take a look at that. So therefore, any values less than, it changes. So this is our y equals what? Sine theta minus 30. So you can substitute any value for your theta. So here we have 90 minus 30. So you have sine 60 degrees. So it takes you to wherever you are. So you have this graph here for y equals sine theta minus 30 degrees. So adding and subtracting any amount from the bracket, we call it a horizontal shift. So the graph moves in a horizontal direction. That is if any value is added to what? To your theta, to your angle in the bracket. Then also we have transforming the graph in of y equals to minus sine theta. So we have our sine graph here. We want to transform it by minus sine theta. So if we have minus sine 90 degrees, will give us minus 1. So you see that our 90 degrees point is on minus 1 here. Same thing for our sine negative of 270. So the graph will just be reversed to this direction. So when you plot the graph, this is what you have for values of y equals to what? Minus sine theta. So the reflection is in the what? In the x-axis. So the change or the transformation of the graph when you have a negative value for your sine is what? In the y, in the x-axis. So this is what we have here. Also the same thing, if you have y equals to sine minus theta, same thing, I have sine minus 90 degrees, give us what? Negative 1. So it's still the same thing. So in whatever direction it is reflected in your y-axis. So it will have the same value for y equals to minus sine theta, and y is equal to what? Sine negative theta. So transforming of our cosine graph when y is equals to negative cos theta. This is y equals to cos theta. This is the graph, our cos graph here. Then when y becomes negative of this, is also going to be what? Our reverse graph here. So, which is also a reflection in the x-axis. It's also similar to your y is equal to what? Negative sine theta. So, but it is different when we have y equals to cos negative theta. So if I have cos negative, for example, 90 degrees, we give us what? This point here. So we have negative cos theta. We can have negative cos 0. We give us what? We have a negative 1 here. And cos negative 0. We give us what? We have this at this point here. So reflecting of this on your graph will be affected. Your y-axis is what is affected. Take a look at this. From -1 here, we have what? A positive 1. So this is transformation of your cosine graph. Unlike the sine graph that we have same thing for minus sine theta, and we have minus sine theta to be the same, and sine minus theta to be the same value. And your cosine value is different here. So they are two different graphs for minus cos theta and cos minus theta. So we'll move ahead to solving questions using the trigonometric graphs. We are solving examples using our trigonometric graph. We have this graph of y equals to sine theta plus k. The question says write down the value of k. So we are looking for the value of our k here, sine theta plus k. So on this point here is where we are going to. So this place here is our k. So the value of k for this graph is 1.5. Then what is the smallest positive value of theta that gives a minimum point? If you are looking for the minimum point, your minimum point is this point here. And this point here is the maximum point. So the value of theta giving us a minimum point here is 270 degrees. Then what is the value of sine theta at this minimum point? What do we have for sine theta at this minimum point? Trace it to this graph here. So the value of sine theta at that point is what? Minus 0.5. So we have our y value there as minus 0.5 for theta. Okay, I hope you understand that concept. We have this graph of y equals to cos theta plus k. And we're looking for the value of k. It says you write down the value of k. So if you take a look at this graph on this axis has been shifted by how many? We have 70, which is what, 90, and here is what, 270. So that means k on our k value here, it is going to be what? 90 minus 70, which gives us what? 20 degrees. Or you have 270 minus 250 degrees, which will also give us what? 20 degrees. So the value of k here is what? 20 degrees. So next we are looking for the value of theta at x. What's the value of theta at our x? So we have value of our angle at x here. At this point here, what do we have here? Theta is equal to what? 250 degrees. Then what are the coordinates of the minimum point? We have those minimum points here. And this side is our minimum point. This is our minimum point. So we have -1 for our y-axis on that minimum point. Then taking it upwards here on this minimum point, just trace to this point, then to this point. So when y is on -1, our x there is what? At angle 160 degrees. So we have our point as 160 and 1. So what is the value of cos theta at y? The value of cos theta at y is what we are looking for. So we're using y equals to what? Cos theta plus k. Y equals what? Cos theta plus k. We are looking for the value of cos theta at what? At this point y here. Okay, so we already know that on the y-axis here, our theta is what? 0. So we are saying that is cos what? 0 plus our k value, which we got from the first as what? 20 degrees. So theta is cos 0 plus 20 degrees. So that gives what? Cos 20. So on your calculator, first cos 20, I think it will give us 0.94. So the value of cos theta at y is equals to what?